Now let's look at it when they're in combination. Okay, so we've already talked. Well, let's since we're already on this part. Okay, that's what we just did. All right. Now the equivalent resistance of resistors in series is always greater than any individual resistance in the series. The equivalent resistance of resistors in parallel is always less than any individual resistance in the array. That's kind of a nice conceptual question. All right. That's a nice conceptual. So when I'm adding up resistances, of course they're going to be greater than the sum of their parts. But if I'm taking reciprocals, even if I take the very smallest one, when I'm doing those reciprocals, it's going to come out to be the resistance is going to be less than the total resistance is going to be less than the smallest one in there. Now, let's take a look. Let's just take a look at this. I'm going to write this down, and then we've got to take a look at how the heck do we break this down into its pieces. Okay, if I was given something like this, notice this is 24 volts, I want to come up with the equivalent resistance. Okay, I want to come up with the equivalent resistance. Well, look what happens here. Look what happens here. Okay, boom, this total current comes out here. The total current actually flows through here. Okay, so this is I total goes screaming through this one. All right, because there's no break off from it. It's the total current coming out of that battery. And then an I2 comes down here, and then an I2 comes this way, and an I3 comes this way, and it breaks into two pieces. I3 does. This I3 breaks into two pieces, and I4 would go here, and I5 would go here. But then they'd come back together again and be I3 right here, and then they'd flow through here. And there's going to be a voltage drop, blink, blink, here. It's going to go from plus to minus, 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 and then flow. And then everybody's going to rejoin again and come through here. But let's find out what the total resistance is. Well, we know that these two have the same voltage drop between them. The plus to the minus here, let's say for just argument's sake, it's 3 volts. I have no idea what it is. But let's, for argument's it's 3 volts. 3 volt drop. 3 volt drop here because they're in parallel. So if they're in parallel, I've got 1 over 2, which is what they're doing here. Well, they're multiplying and dividing by the plus, which is an old electrician's trick, which works great if you have 2 of them. If you've got more than 2 of them in parallel, that doesn't work. So you got R3 and R4, boom. So you figure out what that resistance is. It comes out to, so you've got this R of the parallel in 1 would equal, this actually comes out to be 1 over R3 plus 1 over R4 taken to the minus 1. All right. Okay, so that came out to be 1.5 volts. Then you got 2.5. Okay, so then you got these two guys in series. So you leave them in series. So you got the 1.5 and the 2.5 comes out to be 4. Okay, and then come on this way. Now, hold on. Looky here. I've got these two guys. These two are in parallel with each other. Okay, they have the same voltage drop because I can get to the battery terminal from each one of these. Now I do have to go through a resistance here for this guy, but these two guys are in parallel. Okay. But this guy didn't have to go through a resistance. So again, take the 1 over 4 plus 1 over 4. That comes out to be 2 over 4. You flip it over, you get 2. Okay? So then now they're in series, and so the total resistance there was 8. All right? That was pretty huge. All right. So we'll look at one in the book here real quick. In the next movie.